So I recently did my first weekly live stream, which I'm doing every Monday night at 5 o'clock Pacific, 8 o'clock Eastern. And right at the end of that live stream, somebody asked me a question in the chat. And it was as I was wrapping things up, I didn't get a chance to fully address the question. So I wanted to address that question here. So today we're going to be talking about how you can know if a function has a root within a specific interval. I'm going to show you an example problem that falls into this category and methods that you can use to solve similar problems on your own. So let's go ahead and jump right on into the example. So here's the problem that I got right at the end of that video. Explain how we know that the given equation must have a root in the given interval. The equation that was asked was something like this, where we have negative 2x to the fifth plus 9x to the fourth minus 7x cubed minus 11x equals 0. And the interval that we're looking at is from 3 to 4. So when you're looking at a question like this, what you want to think about is what a root is. Well, a root is basically just where this function, which we can use, basically this function, which is just the left side of our equation, where does this function intersect with the x-axis? Or in other words, where does this function equal 0? Well, of course, we don't really need to actually figure out where it equals 0. We just are trying to show how we know that there is a point between 3 and 4 where it equals 0. Or where an x value between 3 and 4 where it equals 0. Well, to do this, what you want to do is think about the fact that this is a polynomial. This function right here is a polynomial. A polynomial is just something that has this kind of general form where we have, some sort of constant, maybe an x term with a coefficient, an x squared term with a coefficient, however many of these terms added or subtracted together. All you really want to keep in mind is that they all have a coefficient, which is what this x0, x1, x2, xn is, and each of the x's is raised up to a positive integer power. Of course, there could also be a constant that doesn't even have an x with it, but this is the general form of a polynomial. Well, one thing that we know about polynomials that's pretty interesting is that they are continuous everywhere. They're continuous for any x value. What that means is, if we're trying to show that there is a place where this function crosses 0 between 3 and 4, if we know that at one edge of that interval it's above the x-axis, and then at the other edge of that interval it's below the x-axis, it must cross at some point since it's continuous everywhere, since it's continuous at least on this entire interval. So what we can do is if we plug in x equals 3 into this function here, and then we plug in x equals 4 into this function here, we see that when x equals 3, this function is above the x-axis. It's at positive 21. And then when x equals 4, this function is below the x-axis. It's at a negative 236. So if we're positive at the left edge of this interval, and then we're negative at the right edge of the interval, and we know the function is continuous throughout this entire interval, it must have a root somewhere in that interval. So I hope you found this video helpful. If you did, please be sure to hit that like button down below, and be sure to join me on our weekly live streams that we're doing Monday night, 5 o'clock Pacific, 8 o'clock Eastern. Got a couple other videos over there that I think you might like. Feel free to check those out. Thanks, and see you on Monday night.